In this video, I'm going to show you how to collect information from torque angle, transducer, and ultrasonic load data from the bolt. This would enable us to collect torque, angle, and load data while we're tightening the bolt. This is the setup that I have, the simple setup as I used before. We have a bolt with an ultrasonic sensor glued on top, and I have a fixture which holds the torque angle transducer, which has the ultrasonic pickup option on it. We have a load cell here, but we use this load cell right now just for as a joint, not as a load cell. So we will not be collecting data from this connector. We only be collecting from these two connectors. And this is how we have connected it. Torque angle goes to channel 1, and the ultrasonic data goes to channel US1. We have this connection, but we're not going to be enabling it. But in another video, which we will be using all at the same time, that will be another video. So let's go and start the software. So this is how we start the software. First of all, we have to calibrate the torque angle transducer and set other parameters for data collection. Let's start with that. Acquire setup. We start from the analog input. We have channel 1 enabled, which is torque. Click on configure, and let's read the sensor. Read the sensor, transfer the information. So we have 160 Newton meter, that's the units. In our fixture, we calibrate this, start cal. It's calibrating torque with MC950. So this needs to be close to 0. So click OK. Let's go make sure our angle is also enabled and our count per revolution is correct. In this case, 1440 for this transducer. Next step is file name. We have to give a place to store this, the file. Let's store it in data directory. So the file name will be test, and the sample number will be 1. So as we collect data, this will increase the sample number. This is autosave, and also we clicked on 0 analog input before ARM. This will zero out any analog input that we have. Sometimes we don't need this if we are working with very small torque or very small loads. So you need to disable it. But in this case, it's a good idea to have it on. Next is recording. We time-based recording. It's always a good idea to do time-based recording when you have a tension involved, because in time-based recording, you might not have any torque, and no movement. So, but you might have some load loss. So it will continuously measure that. So make sure you're on time-based. And our samples per second is 1,000 samples per second. And let's increase our sample time to 10 seconds. And the rest, we're going to trigger on channel 1, which is torque, and we start recording at 10 Newton meter. And we have 10% pre-trigger. Okay, we are set for that. If now we want to add the ultrasonic, we go to use setup. So let's start from top. We have one channel and one bolt. Let's enable the ultrasonic dynamic recording. This would combine ultrasonic with torque angle data. If you do not check this box, then you will not see this information in your recorded data. So let's go into the config bolt. We have one bolt and 10.9, and our load is based on, let's use average calibration load that we have generated before. In previous video, you saw how we generated that calibration file, which was M10 average cal file. So we have this, we're going to use this calibration file, average calibration file for our load data. So our ultrasonic will be reading time delay, and using this graph, it will show us what the load values are. So, and we are ready to go. Bolt echo number 1, and bolt length is 2.2 inch. Scan echo, same, 0 out, save echo. We can monitor it, and you can see that we're using average calibration 1, and there's some offset here. This offset is from your average calibration file that you generated. Don't worry about it, it's fine. It's just for linear regression results. So we're done with this, we exit this. As you see here on the right hand side, there is a green channel, says channel 1 kilonewton A1 nanometer. It means we have a loaded and locked bolt, so it's enabled. So now we have to set up our graphs, what we want to see. We can have single, double, or quad. So I like the double, so I can see both. Let's say on the bottom, right click, again, graph setup. I can say alpha. Let's look at the channel 1, which is Torqque. Then look at the angle 1. Then we add the U1 tension. You can have, sorry, we have to go back. I wrote angle 1, and third item would be the U1 tension. That's ultrasonic tension, channel 1. Okay. So this is what we'll see, and I can program this top one, graph setup. We can have as a real time access. Make sure in this data dynamic recording, I like to use time because it makes it easier to see when you do very slow type of tightening. So we have time. Y1 is our channel 1. Let's add Y2 as U1 tension. X can be angle or time. Let's just use time for now. And then I can add number 3 as angle if you want. Okay. So one thing we can do, we can just click on scope. It will just show you the data. It will not collect any data. It's not recording. It's just showing you the information that's collecting. If you want to start recording, you can stop and click on R. So on R, let's move this side. You can see you can zero the ultrasonic. Right now it's close to 0. So it's waiting for 10 Newton meter. That's the 10 Newton meter. That's the parameter we set before in this acquired setup. And after that, it will take data for 10 seconds. So I'm going to tighten this bolt. So it triggered and it's taking its time and it's done. So what we have here is let me put this on there. We have torque, and we have tension, and we have angle. Both of them are the same color. So we would like to change one of them to different color. Let's right click. Angle, I can change the color on angle 1. Different color so it can distinguish. Yellow, red, maybe purple. So if I move this around, once I have this button enabled, this cross would attach itself to the graph so we can see what's going on. We have up to 37 Newton meter of torque and tension of 22 kilonewton, and we rotated 74 degrees. That is one view here. If you want to see this in a bigger graph, you can right click, do the same thing. And let's say graph type, we have real time. X is our time. Y is, we can in here, if you like, we can put it as angle here. y1 as a torque, and y2 as u1 tension. So that shows, if I go there, it shows torque, angle, ultrasonic, u1 tension, and torque, all at the same time. This is basic way of collecting dynamic data. In future video, I will show you another way of using the same setup for different type of bolt calibration.